this is number 4. Okay, so I label this. So let's do this together. Okay, so this is for indeterminate power. Okay, so if you watch the lesson, so you know the indeterminate power. Oh, there's different type, right? Okay, so what is this type? Okay, let's try to investigate what happened here. So you see that when x go to infinity, see this x here is in the base, so that will go to infinity. Okay, so that's the type infinity. And then what happened to the exponent over here? This ln of a is a positive constant. 1 plus this part over here go to positive infinity. So this goes to positive infinity. As x goes to positive infinity, ln of x goes to positive infinity. Now, this positive constant divided by a quantity that goes to positive infinity will go to what? What do you think it's going to go to?
0.
It go to 0. So this part over here, it go to 0. Okay. Now let me write down. So as x go to infinity, ln of x is going to go to infinity. So ln of 8 divided by 1 plus ln of x is going to go to 0. And it's going to, okay, so it go to 0. So this limit here is infinity to the 0 power type. So it's indeterminate power, okay? So this is indeterminate power. Okay. So you shouldn't jump into any conclusion because it's indeterminate. So what should we do over here? Now remember in the lesson we talk about when we deal with indeterminate power, what's the strategy?
We bring the power down, right?
You take ln of this function, right? So we let this whole thing that you take limit with, okay? Let that to be y, okay? So we're going to let y to be this, okay? Y to be the function that we're taking limit with. Okay, so let y equal this, and then you take ln of this. Okay, so we take ln of y. That's equal to ln of this whole thing. So that will be x to the ln of 8 over 1 plus ln of x. Okay, so we have this. Now remember for ln, this exponent, you can bring it in front of ln right here. So it's going to, by the property of ln, okay, log function. So this become ln of y. Now this become ln of 8 over 1 plus ln of x. Okay, so you see that this will drop to the front, and that now you have this ln of x right here. Okay. Now instead of taking the limit of this function, we're going to take the limit of ln of this function. So we're going to take the limit of ln of y. And then later we can go back to find the limit of the function. Okay. So we're going to take this limit as x go to infinity. And what happened to ln of y? Well, that's equal to go to infinity, this ln of 8. Okay. Then ln of x, 1 plus n of x. So we're taking the limit of this. Now let's see what happened. Let's see what type is this limit, okay? When x go to infinity, we know that this is going to go to infinity. This is going to go to infinity also. So, and this is a positive constant, okay? So we're going to get a type. What type is this? Do you think? What do you think? What type of limit? This?
Infinity over infinity.
Infinity over infinity type, right? And now we say that it is infinity over infinity type. It is one of the two emergency type. So can we rush this to the hospital, apply L'Hopital's rule?
Yeah, no CPR.
Yeah, right. So using L'Hopital's rule, okay, so rush to the hospital, okay. So we have this limit as x go to infinity. Now, L'Hopital's rule says that we can differentiate the numerator and denominator, and they will have the same limit over here. Okay, let's differentiate the numerator here. What's it? Okay, Ln of a is just a constant multiple, so we just copy it. So Ln of a. Now we're going to differentiate this Ln of x. Okay, what's the derivative Ln of x with respect to x?
1 over x.
Over x, so we get 1 over x. Now, we're going to differentiate the denominator. The derivative of 1 is 0. The derivative of a constant is 0. So that will be derivative of 1 is 0. Derivative Ln of x is, again, it is 1 over x, right? Okay. Okay, now we want to simplify before you do any, apply any other rule, okay? Always try to simplify first. And you see that you can actually divide out this 1 over x over here, okay? So therefore, that will become this limit of Ln of 8. Well, Ln of 8 is a constant, okay? The limit of a constant is going to be this constant itself, so it's not going to change, okay? When x change, this constant is not going to change. So this limit over here will be Ln of 8. Now remember, we are not done, okay? This one over here is the limit of Ln of y, okay? Well, we are trying to find the limit of y, okay? Remember this one here is the limit as x go to infinity, Ln of y, okay? And what we are looking for over here is this limit of the function y, right? The y right there, okay? So now we try to relate this, okay? Now we call that e to the Ln of y, okay? Remember, exponential function composed with this Ln function. These two are inverse function. So when you compose them, they will reverse and give you back this y over here. So that's equal to y. Okay, that's equal to 1. So remember this. Okay, remember this one over here. Okay. Okay, so now because we found the Ln of the limit of Ln of y, now we try to find the limit of y. So we can relate this y with this, okay, in this way. So this is limit as x go to infinity, e to the Ln of y. Exponential function is a continuous function. So when we take this limit, then this will become e to the limit of Ln of y right here. Okay, so you can bring this limit over here in. Okay, and we know that when x goes to infinity, Ln of y goes to what? Ln of y goes to this, right? Go to Ln of 8. So that will go to Ln of 8 right there. Okay, as x goes to infinity, Ln of y go to Ln of 8. Okay, so therefore, now finally, okay, again, over here you see that this exponential function with base e, this is a log function with base e. These two are inverse function, so they reverse and give you 8 over here. So the answer here is equal to 8. Does that answer your question?
Yeah, yeah.